Now let us see how logarithms can be useful in solving equations and inequalities which involves a variable which is in exponents. So question number 1 is we have to solve this equation which is 2 raised to power n is equal to 1000. As we know that 2 raised to power 10 is 1024. Okay, and 2 raised to power 9 is 512. So this 1000 is in between 1024 and 512. So that means that n has to be between 9 and 10. First thing is this. Second is that since this 1000 is more nearer to 1024 as compared to 512, so this value of n should be closer to 10 as compared to 9, and it is more towards the mid value of 1024 and 512. So I think what I am guessing or estimating the value of this n is it should be around 9.8 or 9.9, somewhere between this 8 or 9. Okay, but what is the exact value? So here comes the role of logarithm to find out the exact value of this n. So exact solution will be that we will take the logarithm of this equation on both the sides. So this is 1000. So taking log, this will turn into n log 2 is equal to log of 1000. And I'm taking log with base 10. Okay. If there is no mention of base, we take the log, we take the base of log as just 10. So here it is n log 2 is equal to log 1000 with base 10. That means n log 2 is equal to, I can write this as 1000, which is log 10 cube with base 10. So this is just 3 log 10 with base 10, and log 10 with base 10 is just 1. So I have n log 2 is equal to just 3. That means n should be 3 over log 2. Okay, 3 over log 2 will give you 9.965. 9.96. I cannot show you the scientific calculator. I'm just having a basic calculator which is not suitable for, or which is not having the function as log. Okay, it is just basic. So you need a scientific calculator to find out the value of log 2. So 3 by log 2 is 9.965. So I think my estimate was closer because I was estimating the value closer to 10, not exact 9.8, not exact 9.9. So it is more closer to 10. It is greater than 9.9. Okay, and it is also an irrational number. Okay, log cannot give you the exact value. Exact value will be of this, that log 10 with base 10 is 1. Okay, log 1000 with base 10 is 3, but log 2 with base 10, that will be an irrational number, I think. Okay, not irrational, but you cannot, these are just the approximate value. Okay, so 9.965 is the value of n. Second question, there is a geometric sequence which becomes like this, that 0.2 is the first term, this is 1, this is 5. The kth term is the first term in the sequence that is greater than 5 lakh, okay, 500,000. So find the value of k. So since it is given that this is a geometric sequence, so we need to find out the value of common ratio, that is r. So just to verify that am I getting the value of r as same or not? So yes, I am getting, because this is 5 and this is 5 by 1, means common ratio is 1 by 0.2 must be same as 5 by 1. Okay, so this is 5 common ratio. Now it says the kth term is the first term in the sequence that is greater than this. That means kth term, as you know that the general term for a geometric sequence is given by ar raised to power n minus 1. So a r, instead of nth term we have kth term. So I'm writing this as a r raised to power k minus 1, and this term is my first term which is greater than 500,000. Okay, putting the values of a and r in this equation, value of a is 0.2 and r is 5 raised to power k minus 1. This is greater than 500,000. Okay, that means this is, I can rearrange the term like this: 0.2 divided by 5, taking this 5 raised to power k upon 5, so 0.2 upon 5 into 5 raised to power k, this is greater than 500,000. I think this is 0.2 upon 5 is 25. So 5 raised to power k is greater than 25 into 500,000. That means 5 raised to power k is greater than 25 into 5 is 125 into 10 raised to power 5. Okay. Now taking log on both the sides, this will give me k log of 5 is greater than, this is 5 cube I think. So 5 cube and log of 5 cube into 10 raised to power 5. Okay. Again, applying the properties, LHS will remain same. K log 5 is greater than log 5 cube is 3 log 5 plus 5 log 10 is just 5 because base is just 10 if it is not written. Okay, log A into B is log A plus B, and log A I have written like this. This is 3 log 5 plus log 10 is super 5 is just 5. Now K is greater than 3 plus 5 over log 5. Okay, so I just need the value of 5 over log 5, which is 7.153. So K is greater than 3 plus 7.153 and so on. So K is greater than 10.153. So now as this is a geometric sequence, sequence means the terms which is n or this k should be an integer, positive integer. It should be a natural number. So fraction values or decimal values are not possible because there is nothing like 1.5 terms or 10.1 terms. Either the term will be 10 or either term will be 11. So we have to find out a value of k such that this k should be an integer and this should be greater than 10.153. So the next value, which is just the next integer, which is closer to 10, is 11. Okay, so k is 11. Right? So condition here is that we have to find the value of k which is greater than 10.153, and since this k has to be an integer, so the immediate integer for this 10.153 is just 11. Right? So meaning of this question is that this is the 11th term in this sequence which will be greater than first term, will be the 11th term which is greater than 500,000. Okay, all right.